All right, let's talk about collections, the list interface. This will be the first in a series of talks about collections. And while we're talking about the list interface, there's a question that needs to be answered. Array list versus linked list. Which one should you actually use? But in order to talk about this topic, in order to answer this question, we have to know what the list interface does and what it's about. So we're talking about collections that implement the list interface. And the thing you have to know about lists are ordered collections. Ordered means that the order is based on insertional. So an element with an index of 0 is inserted before an element with an index of 1, and so on and so forth. It allows duplicate elements, and it also allows index-based access to retrieve, insert, delete, and replace elements by position. Now let's talk about the different types of lists. So here are the concrete classes that implement list. You have ArrayList, LinkedList, and vector. I'll talk about vector first because I just want to get it out of the way and not talk about it again. So vector is a legacy list. It was originally made to be thread safe. So ArrayList. We have ArrayList and we have LinkedList. So ArrayLists are backed internally by an array. As you know, arrays are fixed in size. However, ArrayList is a resizable array implementation of list that provides fast random access. So you can access elements fast because they're index-based, but slower insertions and deletions, especially in the middle. I will show you what that means. But what it means, and I'm telling you this, is that whenever you insert or delete an element from an array list, you have to shift other elements around. You have to shuffle other elements to close that gap. You'll see in a minute. Linked lists, on the other hand, are backed by a doubly linked node implementation of a list. And it allows fast insertion and removals, but access is slow. Okay, so this will help us answer our question. What do you use an array list versus a linked list? I can tell you that in practice in an industry, the vast majority of the time, you're going to use an array list. There's very little a linked list can do that an array list cannot do, except faster operations. And when I say operations, that means insert to delete. That's what I mean by operations. And I say that because that's what your interviewer will mean by operations. All right, so this is that table that we looked at during Introduction to Collections. Now we can go over this in a little more detail. So it's all the same information. So ArrayList, LinkedList, and vector, they all implement the list interface. So that means that they take the abstract methods from the list and provide their own implementations. They're all ordered. That's what makes them lists. They're all ordered based on insertion order. They all allow duplicates, but they are not sorted. If you want to sort them, then you have to call a method for that. Usually something like collections.sort. All right. And of course, linked list also implements queue, but we'll talk about that another time. So here we have ArrayList, and this is insertion and deletion. Now, as we can see here, when you insert an element, you have to shift these other elements around. That means you have to iterate through this list in order to do that. So if you're talking about time complexity, that's an O of n. That's linear time complexity. And the same for deletion. When you delete an element, you have to shift elements around. So I hope that this picture drives the point home. But accessing is easy. Okay, I want the element of index 3. There it is, right there. It's constant time. Linked list, on the other hand, is a little different. So insertion is very rapid. And that's because all you have to do is change some pointers around. You literally just rearrange some pointers. Deletion is the same. You just rearrange some pointers. Access is a little slow. So this comes to indications for use. So as I already mentioned, modern Java developers almost always choose ArrayList by default. You switch to a linked list when you have heavy insert remove operations that do not involve indexing. So if you're primarily doing operations and not indexing, which is very rare, then that's when you would use a linked list. Okay. And I also have here avoid vector because we use collections.synchronized list or concurrent collection instead. Okay, I'm just going to touch on this too, because the reason that you only use vector in legacy code is because it adds additional overhead for operations that are not multi-threaded. So in general, use ArrayList for general storage, linked list for frequent structural modifications, and vector only for legacy synchronized code. I'm going to put this another way. If in doubt, just use ArrayList. You're going to end up using ArrayList. But if they ask you why you would use a linked list, you would say, if you have a list that requires a lot of operations, these operations being inserting and deleting, and you're not indexing, you're not accessing these elements frequently. That's the interview answer I would give. Okay, now let's talk about some methods unique to the list interface. I'm only going to touch on these because there's an exercise that we're going to do, and we're going to use all these methods, except this list iterator method. I'm not going to use that. I'm going to use the for each and set, but they're all self-explanatory. Add, add all, get, set, these are very common. So add is self-explanatory. You add an element to the list. Add all is you take a collection of elements, add that to the list, and you add it at a specific position. Okay. Get is you can get by index. You get by index. So you pass in the index, you get it at that index. Set is you set an element at that index. You can either set by index or you can pass the element itself and set it by index. Actually, let me rephrase that. You replace an element at an index. Remove, you can remove by index. You can actually pass in an object as well and just remove it. Index of is you get the first occurrence position. So if you have, let's say, 2 occurrences of an element in the list, you find the earliest position, the lowest index at which that element appears. Last index of is you find the last occurrence position. And then list iterator, I'm not even going to talk about them. You can read them for yourselves. Sublist is and from index to index. It's kind of like substring. It's everything from that index up till but not including the last index. All right, let's go. Let's go and have some fun and work on our ID. All right, fellas, we are back in Eclipse. So let's go through these ArrayList methods. And these ArrayLists also work for linked list. What I'm going to do is I'm going to go through these exercises with ArrayList, and then I will repeat 1 or 2 exercises with linked lists. I can tell you that in this case, the exercises will run the same whether you're using linked list or ArrayList. And this is just an example of relying on abstractions rather than concrete implementations. Anything that you can use anything that implements a list interface. I mean, we could probably use vector and it'll work, but we don't use vector. All right, so let's talk basic add-in. So let's uncomment this out. We'll hit save. Let's run this. So we added 3 students, and it's going to print out a list of 3 students. There you go. Easy peasy. Next, insert add a position. Okay, so we're going to add an element at this index. So we're still adding Alice, Bob, and Charlie, but we're going to add David at index 1. So index 1 is the second position in the array. So this is our initial list. Remember that. All right, let's run it. All right, so David has been inserted into the second position. Easy peasy, right? Next, retrieve element, get. All right, let's do this. So we'll run this. So we're going to get an element at index 2. So it's going to be the third position of the array. So my guess is we're going to be getting Charlie. Let's see what we get here. Ooh, Charlie's in the house. All right, let's go. Next, replace an element. All right, so we're gonna replace the first element with Zara. All right. All right, Zara's in the house. Zara is now in this list. She has replaced Alice. All right. Next, remove an element. And comment this out too. All right. So we will remove at index 1, which is the second position. So Bob has got to go. Bob's gone. Where'd he go? All right. I'm having a little too much fun here. Okay, let's move on to that next exercise. Okay, now we're going to search using index of. So as you recall, index of returns the first position of an element. Last index of returns the last position. So first Bob. So index of Bob. So we got three Bobs. Last time we removed Bob. Now we got 3 of them. So the first index is going to be 1 because it's arrays and ArrayList is 0 base. And the last index is going to be 1, 2, 3, 4. 4. So let's go. And let's save this. I got carried away. Yeah, man. Am I good or what? All right. We're already on exercise 6. Exercise 7, baby. Exercise 7. Okay, so we're adding our usual players, but we're also going to add a list of elements, Eve and Frank, and we're going to add it at index 2, which is the third position. So let's see what we get. Let's go. So this is the original list. We're inserting these 2 players. So we inserted Eve and Frank starting at position 3. So Eve and Frank, Charlie got shifted over. And this is another point I want to make. Whenever you add or remove something, you're going to shift elements, which means you have to iterate through the list. So the time complexity is O of n. It's linear time complexity. All right. Maybe one day I'll talk about space and time complexity, but I'm not there yet. All right. Let's go to 8, sublist. So the thing about sublist is it's kind of like the list is giving you access to a view of a certain part of the list. However, if you make modifications to that sublist, you're modifying the original list as well. Okay, so we're adding these 5 players. We're gonna print them out. Then we're gonna get the list from 1 to 4. So 1, 2, 3, not including 4. Because that's the thing about these sublist and substring methods. It's up until but not including the last index. I don't know why, but that's just how it is. And then after we get the sublist, we're going to modify the sublist at index 0. So we're going to modify the first element of the sublist, which will be the second element of the main list. So Bob is going to become changed. Okay, so let's print, and then we'll print the group and we'll print the new list. So let's go. Okay, so here's the original list. This is the sublist 1 to 4. Bob, Charlie, David, not including 4. Here's the sublist that it's index 0. Index 0. So we changed Bob to changed. And then, but see what it did in the original list? So this is the sublist. So if you make changes in the sublist, you're changing the original list. All right, next. Okay, clear. Okay, so here we're going to clear a list and use the isEmpty method. So we're going to clear the list and then we're going to state that the list is clear. All right. So we're just going to empty the list and then say the list is empty. IsEmpty is a Boolean. That's why it's called isEmpty. Initial list has these 3 players, these 3 students. After clearing the list, it's empty, list is empty, true. Shocker, right? All right, so let's talk about iteration. So instead of that iterator method, I'm going to use the for each. And so we're adding these 3 players. We're printing their original, we're going to just print a header. And then notice that for each does not return anything. So if you know about for each in JavaScript, for each in Java is pretty much the same thing. It takes in it takes in a consumer. So basically it takes in an element, but it doesn't return anything. And in JavaScript, it's called the iterator of no return. Remember it that way. Okay, let's run this before I start talking too much. All right, so it printed student Alice, Bob, and Charlie. So that's what you do for each. It's good when you want to output to a console. But if you want to return something, then you end up using a map method. But we'll probably talk about that when we get to streams. Okay, so this is an interesting scenario. This is probably something I'm going to have to expand on. But I'll talk briefly about it. So we're going to demonstrate a concurrent modification exception. Essentially, what it means is that if you're reading a list, so if you're accessing a list and you're trying to modify it at the same time, it's going to throw a concurrent modification exception. So a concurrent, some people may overthink this and think, oh, this is threading. It's multiple threads trying to access a list. It's not multiple threads. It's just like, try to think about it, right? I'm reading a book, right? And some fool comes and tries to take the book away from me and make changes while I'm reading the book. And then that's kind of like how a concurrent modification exception is. You're using a resource and somebody else is, and something else is trying to make a change. You can't do that. And this is especially true with the sublist method because you're trying to make a change, you're trying to remove a resource. But I'll get more into this some other time. So let's go. See, through concurrent modification exception. All right. So now, as I promised, I'm going to redo these exercises. But instead of ArrayList, we'll use LinkedList. Okay. So let's uncomment this. We can just uncomment this part as well, because it'll insert. We can also retrieve an element. The top is just repeated code. Replace an element. Okay. Remove an element. I think that's enough. Okay. Everything ran as expected. Everything ran as expected. So that just shows that in the day-to-day activities of a software developer, you're going to default to using an array list because there's very little a linked list is going to add to your workflow. Like I said before, unless you're doing frequent operations on the list and not reading, not accessing elements from the list, that's the only time you're gonna use a linked list. But I'm trying to think of a scenario where you're gonna be doing operations and not accessing the list. If somebody knows, please let me know in the comments. Don't forget, love this video, subscribe. I'm out. Peace.